This is the FAQ video for section 5.3, day 2 in pre-calculus. Looking at number 8, it says use a sum or difference identity to find an exact value, and we want tangent of 11 pi over 12. So one of the things that you can do that makes this a little bit easier is just to write down all your multiples of pi over 12, because we need that common denominator for all of the nice ones that we have on the unit circle. We've got pi over 2, pi over 3, pi over 6. The least common denominator would be 12. So what you first want to do is just get used to all of those numbers. Now, notice that I didn't reduce any of these yet, because the ones that I want to use to find these exact answers that we need for the sum or difference identities are the nice ones that show up on the unit circle. So pi over 12, that's done. There's nothing I'm going to get with that. But 2 pi over 12 will give me pi over 6. 3 pi over 12 will give me pi over 4. 4 pi over 12 would give me pi over 3, and here I am writing a 12 down again. So it's the nice ones. 5 pi over 12 is not going to be helpful to us. 6 pi over 12, these are the nice ones that we want. And what we want is to find a combination here that would work for 11 pi over 12. And right away when I looked at this, I thought, well, what about 8 pi over 12 and 3 pi over 12? So that would give me pi over 4 and 2 pi over 3, but together that would add to tangent of 11 pi over 12. So I want the tangent of pi over 4 plus 2 pi over 3. And that formula is the tangent of pi over 4 plus the tangent of 2 pi over 3. Because we have addition inside there with the pi over 4 plus the 2 pi over 3, that sum, we want addition in our numerator. It's like it takes center stage. And then it'll be 1 minus, because we have the opposite sign for the denominator, the tangent of pi over 4 times the tangent of 2 pi over 3. So now it's pretty obvious that what I need to do for this formula is figure out the tangent of pi over 4 and the tangent of 2 pi over 3. Well, hopefully the tangent of pi over 4 was something that came to you right away, because that's the tangent of 45 degrees. And that's going to be 1 over 1, which is 1. And then for 2 pi over 3, you might want to draw yourself a little reference triangle for this one so that you can remember exactly what's going on with this. Because this would be a 60-degree angle, this would be the square root of 3, and this would be negative 1. So when we want the tangent, where we want opposite over adjacent, that's actually going to be a negative square root of 3. So the tangent of 2 pi over 3 equals a negative square root of 3. And we need to just do some substitution here. The tangent of pi over 4 is 1, plus the tangent of 2 pi over 3 is a negative square root of 3, over 1 minus the tangent of pi over 4 is 1, and the tangent of 2 pi over 3 is negative square root of 3. So a little bit simplified here, we'd have 1 minus the square root of 3 over 1 plus the square root of 3. And with this, we are going to rationalize the denominator. So we would use the conjugate. We would multiply by 1 minus the square root of 3 on the top and the bottom, because we're manipulating. We're changing the way that it's looking. But we truly are, in the green, just multiplying by 1. So I always take care of the denominator first. I want to make sure things are going to work out nicely. So first times first would be 1. Outside times outside and inside times inside will cancel out. Last times last will be a negative square root of 9, which is minus 3. So that's good news. I get a negative 2, which is an integer, no radicals, in my denominator. Up in the numerator, 1 times 1 is 1. Outside times outside would be a negative square root of 3, and so would inside times inside. And then last times last, negative square root of 3 times negative square root of 3 would give us a plus 3. So that's going to be 4 minus 2 square roots of 3. And last but not least, I certainly can divide that. So that would give me -2 plus the square root of 3, which could also be written as the square root of 3 minus 2. Either way, there would be the appropriate answer. That was it.